Good morning, everybody. Thanks for joining us here. Thanks for joining us here today. I hope this gives you what you need in order to understand who we are and what we're up to. So I'm Chris Hammond. I'm director of the Center for Advancing Safety of Machine Intelligence, or CASMI. I'm joined today by Sarah Spurlock, who is the associate director. Today we're going to talk about the mission of CASMI and how we actually view the world of safety and our current call for proposals sort of both in terms of the content that we're looking for and the nuts and bolts of how to go about applying to these for this award. Well, let's start off. We'll talk a little bit about the mission and where we came from. So the Center for Advancing Safety of Machine Intelligence is a collaborative effort between Northwestern University and Underwriters Laboratories Research Institutes. The whole point of the center and the mission of the center is really pretty straightforward, and that is what we're doing is we're trying to put together a program focused on the evaluation, design, and development of machine intelligence that is safe, equitable, and beneficial. And the notion behind this is that while there is a lot of discussion of ethical AI, responsible AI, transparent AI, explainable AI, we don't think that there's enough discussion of how to actually operationalize those notions. That is, how to turn those notions into particular steps that we could take to both evaluate systems and to design those systems. So the focus of CASMI is actually that particular vision. And the way we're going about it is actually to use not only our internal researchers, but actually to develop a network of researchers. Because the reality is that this is a huge problem. As AI reaches into all aspects of our lives, we really have to consider very straightforwardly the issues of how to make it safe. And rather than thinking that what we're going to do is we're going to build a huge group within Northwestern, our approach is to create a network of researchers and practitioners who actually agree with the mission and are working towards the mission, and that we can partner with. And that gives us not only a broader reach, but it gives us a much broader range of expertise and perspectives. And in this call, what we're doing is we're looking to expand this network and create an ever-growing network of researchers working on aspects of this problem that can be then drawn together into CASMI as a research hub.
And as Chris said, that's the reason behind our call for proposals that we've just recently issued. We want to identify compelling new research initiatives that will move the needle toward CASMI's research mission, in particular priority focus areas, which we'll talk about in a moment. We're looking for projects that would be up to a maximum of $275,000 US for total budget and up to 2 years in duration, with the expectation that they'd likely begin work in January of 2023. An eligible PI from any research institution can submit a proposal. This is not restricted to just US or just higher education, but we are looking broadly at organizations and at researchers who would align and have the capabilities to achieve their objectives toward their project goals. We do need proposals to be submitted by September 26th, and all the information on our call for proposals is on our website. I'll include this link in the chat as well, so that you can see all those details when you can.
So we have a particular point of view in this area, and that point of view is really based upon the notion that we want to operationalize the drive towards the development of safe AI. This point of view really came from an understanding of what the framework for evaluation could look like. That is, our starting point for this was the notion that we would want to look at systems and how to evaluate them from the perspective of how they were built, what is true about them, and then given that, how, as they are being deployed, how are they going to be impacting the world? We developed this roadmap by really going through a 2-year process of having conversations and workshops with researchers and practitioners that was aimed at building out first a framework, and then looking at that framework from the point of view of, given if we were going to operationalize this framework, what research needed to be done in order to make it possible. And you want to think of it as if you've built a model that's based upon the technology of neural nets, understanding what factors go into any given decision or even any given prediction that model provides is not immediately available to you. And so research has to be done about how to actually test that model against those features to actually uncover bias. And the notion here really is the framework for evaluation and the framework for design give us a direction as to what research needs to be done. And what you're seeing is the product of that. Now, the important thing is that both the framework and our notion of what our roadmap is are evolving over time. That is, just as we believe that the research needs to be distributed, the actual framework and understanding the nature of that framework and the nature of the research that it suggests also is distributed. And so we are constantly looking for feedback as to the framework and as to the research to help prioritize those the issues that we're looking at. So the framework for us is fairly straightforward. That is, we're starting. If you think about the sort of the pipeline of developing a system, in particular, developing a system that has a machine learning component, there are a set of things that have to be done, and for each one of those steps, there are issues of making sure that those steps are done right, and thus ensuring the safety of the system. And that goes from the collection of data through choices having to do with the algorithms that are being applied, through the human interaction with the resulting system. All of those define a set of facts of the system. And then, given the facts of the system, we have to go through an evaluation process. And so the evaluation process is really focused on how the system will be used, the domains in which it is going to be used, because that has a tremendous impact on the impact of a system. Now, one of the reasons why we're doing this, and we're trying to have this framework be a part of the vision, is that if you pull back and you look at an AI system and say, well, it's not fair, or it's biased, or it has these ill effects. The problem with that is that that's talking about the system as a whole. And for us, the framework allows us to break the system down into parts and actually look at the real causes of bias, the real causes of lack of fairness, the real causes of ill effects, such as functionally getting people addicted to systems. And the idea here is that we can, by doing this decomposition, we can actually have research within these individual areas, as well as research that might scope across them all. But in particular, what we're looking for is research aimed at these specific areas. So within, within an area such as data, the research there really comes down to doing things like how do you identify errors that are created during data gathering? Are there problems that occur because some features aren't available, and so in data collection we have to use proxies? Are those proxies the appropriate proxies? What kinds of errors occur while you're cleaning the data, normalizing the data, or augmenting the data? And in each of these areas, there is research that has to be done in order to understand the implications of certain kinds of errors, understand how to identify when you have made mistakes like that, and actually even creation of tools that help developers and data designers ensure that they've got the right level of coverage, they've got the right features, and that as the data is being collected, there's not actually bias in that collection process. So there, the focus is on data, but there are other problems that can creep into systems. When you're looking at things at the algorithmic side, there's certainly, we would be interested in looking at projects that really are aimed at core algorithmic improvement. But the reality is that the places where we're sort of most interested are when we're thinking about sort of testing and simulation approaches, looking at the actual models within the mechanisms within the model development process, and where there could be problems. And even given that so many of the models that are being created, so many of the systems that are being created today are based upon proprietary sources. Are there methods for taking a look at black box models and actually testing them to make sure that they don't have a bias that could be detrimental to the users and other stakeholders? Now, this tends to be a well understood. Both of these tend to be well understood areas where research needs to be done. But there's a third component which we think is significant when we're thinking about how to both build and evaluate intelligent systems, and that is how they interact with us. You could have a system that's based upon a model that is perfect, totally unbiased, but because of the nature of the way the system interacts with the human user, it will make mistakes, or it will skew the user in one direction or another. A system that recommends ends up being different, even though the underlying model might be the same, than a system that critiques, because the user starts off in one instance with a suggestion in front of them that frames the problem. In the other instance, they frame the problem. And so outcomes can be different. And so we're very interested in looking at the ways in which people interact with systems and how they actually determine or impact outcomes. And the notion here really is that human beings and machines work in very different ways. And we are very interested in looking at ways in which the machine can help correct for human reasoning deficits, while in fact making use of human skills as much as possible. So each of these three really is in the area of the nature of the system itself. That is the machine, the system that's sitting within the machine and interacting with the human being itself. But once you have actually understood what's going on there, then there's a final moment, and that's an evaluation moment. And this really is an area that is less, an area of pure technology, and much more of an area of what we would think of normally as the social sciences. And so what we're looking at here is how do you evaluate these systems? And that means understanding how to take sort of human goals and values the values of different fields, what are the norms of those fields, and figure out how to measure and quantify them. Because the reality is that it's not as though a system is either good or bad, and that's it. It's not a black or white situation. It's really a situation in which we live in the gray areas. And that means trade-offs between different kinds of outputs. We could have, for example, cars that are perfectly safe. They would be really expensive and go and drive really slowly. And so what we have is a set of trade-offs where we understand that in order to get the goals, the functionality we want out of a car, that there are some risks that that car drivers end up taking. And the same is true of any system that is deployed in the world. And so what we're interested in is understanding what those trade-offs are, how to evaluate those trade-offs, giving people tools and frameworks for evaluating those trade-offs, and understanding things like self-reinforcing cycles within systems that might push, as a result of utilization, might push the impact of the system in a negative or positive direction. So these four components make up our framework and actually define a great deal of what our research roadmap looks like. Now, there was a question that had come up earlier, and I wanted to just really quickly touch on it, and that is, we're not looking for proposals that scope across all of these areas, entirely. What we're looking for is, given specific problems in each of these spaces, in data and algorithms and human-computer interaction, in the evaluation, finding places where we can get some leverage off of research, leverage that will allow us to help evaluate and design systems that are safer. So within data, understanding the causes of problems in the data pipelines, understanding the misalignment between data and task, determining ways in which we can identify the issues, but also mechanisms for not just identifying, but remediating them. And algorithms, looking at the impact of the choices that people are making with regard to how they train and how they test the models that they're building. And given the different types of algorithms that can be applied, whether or not those particular choices impact the transparency or the explainability of the outputs. And likewise, understanding from a human-computer interaction point of view, not just the sort of surface level of whether or not a system is easy to use, but actually what is the interaction design that determines outcomes. Where can we identify those places where we can improve outcomes, not by improving the core underlying AI algorithm, but just improving the way in which people are interacting with these systems. And then finally, really taking a look at what the impact of these technologies is on individuals, on stakeholders, on communities. We're really interested in establishing what it even means when we start talking about a system being safe, because we're not living in a world where we're worried about AI breaking people's arms or bursting into flame. What we're really interested in is a world in which we have AI systems, which even today are imbalanced, are biased, skew decision making in faulty directions, where there's mismatches between the decision making the goals of the user and maybe the goals of the people who develop the systems. And what we want to do is figure out what better ways to integrate the goals and the needs of the stakeholders who are really part of the affected communities, and figure out how to evaluate systems that go beyond the individual user in this one moment in time to thinking about it in terms of communities, society writ whole, and actually the impacts of these technologies over time.
So that brings us to the proposals. We've developed a set of proposal materials or guidelines for the proposal materials, which are also on our website, and I'll share this link in just a moment as well. But the proposal really will have 5 main components. A statement of work, which should be a maximum of 5 pages, and we do have a particular outline we'd like to see, and some guidance for how to explain your project and give us the information that we're looking for in order to fully review and understand what you're proposing. A budget and a budget justification, which will explain how you determined the costs and expenses that you'll have in order to achieve your objectives. A biographical sketch for the PI, and if there are other key personnel, we'd like bio sketches of them as well as a letter of intent for your organization, from your organization supporting the proposal. I'll put the link in the chat in just a moment, but hopefully that will be, the website will fully explain all of those materials and what we need there. Looks like we've answered the questions that are here today, but if you do have more, please reach out to us. CASMI@northwestern.edu is our email address, and you should have our website as well, which hopefully will be able to answer some of the key questions. But as we mentioned, feel free to reach out if anything else occurs to you, or if you'd even just like to chat about an idea that you have for the future. Thanks so much for joining us today. Chris, I think we'll sign off from here then.
I think so. All right. Thank you, everybody.
Sounds good.
And we'll, and if you have more questions, really reach out.